So you're what I think 8 hours in time zones away. So for you it's the middle of the night, isn't it?
Yeah, it's about a little bit past 1 a.m.
Wow. So Venkat, thank you very much for being here still. That's amazing. Um, for the I don't know for the like three people here who don't know you yet, why don't you introduce yourself quickly?
Well, thanks again. A programmer, author, consultant, just about a person who gets excited too easily about anything. So thrilled to be here. Like to write code and talk about code and lessons I learned from it. And I'm really thankful for the opportunity to speak to the audience, developers about things that we deal with every day.
Yeah, so I think you undersold yourself there, right? I mean, you're Java champion, if I remember correctly. You're also like a luminary. Everybody online gets excited when they read your name because you're always doing like, particularly the talks are really amazing. I'm really looking forward to it. And I already have some questions, but I'm gonna like try to stop asking them, so we can ask them afterwards. So if you have any questions, people out there, so there's a chat, of course, you've seen that. There's also Q&A area, which is more formally where you could write questions, but like it doesn't really matter that much. We will pick them up. And maybe Venkat will be able to answer like the easiest ones during the conversation and during the recording. And otherwise, afterwards, we'll do a proper Q&A session where we can talk to him and ask him all of your questions. So yeah, right. So do you want to tell us a little bit about what the talk is about?
Yeah, so one of the things we deal with every single day when we work and looking across different industries and different domains, we tend to really creep very quickly towards complexity. And how many times have we been on projects where we look at the code base or the solutions and say, "Oh my gosh, this really is hard. Why are we doing this?" And so my talk is really centered around how can we really come up with things that are simple. But one of the challenges is we all ask anybody in the world, ask them if things should be simple. The answer is instantaneous. Of course things have to be simple, but the problem is we just don't know what simple really is. And that's exactly what the talk is about. What is really simple? And then, of course, why should we really strive towards that? Not only just in code, but in various other things we do in general, with the various different aspects of software development.
Yeah, that makes sense. I think nobody wants to build complex stuff, but as you said, we somehow always do, and then we're like, why did we end up here? Okay, so without further ado, we're gonna see your talk now, and then we'll meet you later for a Q&A.
I want to talk about something we deal with every single day. It's the complexity. There's complexity all around us, and the only way we can even cope with it is to, from time to time, step back and ask the question, how can we make things simple? And that's what I want to talk about today, is how can we possibly make things simple around us? Well, we all deal with something extremely, I should say, capable every day. That's our human brain. I can't think of anything more capable and more interesting than a human brain. But that excellent brain also gets into the analysis paralysis oftentimes. It's the same creative people who also get tangled up in all this complexity. It's kind of interesting to see how the same very brain that's creating so many great ideas also gets tangled up emotionally with the quagmire of complexity. Wow, that seems to be really bizarre, isn't it? That everything is in one place. Well, as it turns out, we can see this problem in several places. It reminds me of times I used to spend with my children when they were young, talking about, well, after all the things, Schrodinger's cat. Well, the Schrodinger's experiment was about this cat, which is considered to be both dead or alive at the same time. Well, we'll come to that later on, but I would say simplicity is kind of like that, but how so? Well, I'm going to ask the question. We all talk about simple, but the question is, how much can we really make things simple? After all, Confucius said, life is really simple, but we insist on making it complicated. Let me ask you this question. If Mr. Simple or Miss Simple were sitting next to us in the train or on a bus, Would we even recognize it? So why do we really make things complex? Well, the reason we make things complex is, let's admit to it. It feels good to make things complex, isn't it? We feel like a pat in the back. You develop something and somebody looks at it and says, yeah, that's simple. Maybe you feel a little let down. On the other hand, they look at us and say, oh my gosh, I'm trying to understand it. We feel proud about it. We created something worthwhile. Unfortunately, that's misguided, but a lot of us get into the trap of creating something complex because of that reason. Einstein said, any intelligent fool can make things bigger, more complex, and more violent. But he says it takes a touch of genius and a lot of courage to move in the opposite direction. The two words I want to underline here is not actually that touch of genius, but the two words I want to underline is that lot of courage. Well, okay, three words in that case, but the lot and the courage. Well, lot of courage because courage, how many times we sit in meetings and we feel a little frustrated. I got an idea, but I don't know if I want to say it. Maybe people will not really take it serious because maybe it's too simple. So it actually takes courage to stand grounds and say, I don't need to make this complex. It can be done much more easily in a much more simple way. So the question really is, if simple was sitting next to you, would you even recognize it? Would everyone recognize it? Let's talk about simplicity, but I wanted to really talk about what is simple. But as it turns out, that's really hard. Maybe I should talk about what's not simple, and if we talk enough of it, maybe we'll not do those and things will become simpler. At least we can hope. Let's talk about what's not simple. I'm going to say simple is not clever. Let's be honest about it. Have we ever written clever code? All of us have done. Now, when we write clever code, we feel really good about it. I'll share with you one experience I had. I was working for a client. They wanted me to solve a problem. I looked at it. 10 minutes, I could have solved it. But why would I? I didn't want to solve the problem. I want to solve the mother of all problems. So I went on and worked for about an hour. And I had an out-of-body experience. Venkat got up and hugged me and said, that's brilliant. I felt so good about it. But a few weeks went by and there was an email exchange on the client side and they said something has terribly gone wrong in production. I looked at it, immediately responded saying, I'm on it, I'll fix it. Somebody said, of course we know you can fix it because you're good at it. I said, no, I can fix it because I'm the one who caused it. You see, the solution I had created, which was clever, had backfired. I did not know what I was doing. I was so proud of what I was doing. I lost sight of the cleverness of the code that did not work properly in production when the situations changed. What did I do? I rolled back the code, put the solution for the 10 minutes I had in mind, and everything worked fine after that. Well, these days I've learned my lessons. When I write something clever and my mind tells me it's clever, I immediately delete it and start over. So we want to write clear code and not clever code. But of course, we all have seen our share of things. Well, this particular class, enum, E extends enum, E. Let's let that sink in. Class enum, E extends, again enum, E. Well, that noise you just heard, that's your brain throwing an exception. So, but that code works, but there's a lot of cleverness built into it as well. So oftentimes programmers ask me, how do I obfuscate my code? I often tell them, why do you care? Naturally, the programmers write self-obfuscated code. They themselves cannot understand the code after a while. Well, we've seen evidence of this in many places. Well, let's take a look at an example of this code I came across. Well, in square root, float x. I don't know what x is, but here's the good news. Whatever x is, we have half of it. But of course, don't tell me what that code really does. Isn't that beautiful? But here's the beauty of this code. We don't know what x is, but we did a number of things. But whatever it is, we return x right back in the end. Well, that's an example of a very highly complex code. Well, we want to really strive for simplicity. But then again, remember somebody told object-oriented programming or programming in general models the real world. Well, somebody took that to the heart when writing a flight simulator, I suppose. And they created this example of the code. And my question is, where were the adults when this person was writing the code after all? Kind of scary, isn't it? So we don't want to really go overboard in creating complex and clever and fancy code. We want to really create code that actually works, code that actually is clear to understand. I also will say that the simplicity is not necessarily familiar. Well, I often, when I talk to developers, they say, well, that's complex. And I ask them, excuse me, is that really complex? Or are you saying you're not familiar with it? We often confuse familiar with simple. Sometimes what we are familiar with may actually be complex. On the other hand, what we are not familiar with may actually be simple, but we don't even know to evaluate it. So we need to really cautiously keep in mind that simple is not necessarily familiar. Something that is simple may actually be something totally unknown to us or uncomfortable to us, but we have to really learn that to really appreciate it and be able to make use of it. Well, for example, what is this? Well, when I speak in among a group of large audience, usually I'll have people raise the hand and I would ask them, what is it? And they would say, well, that represents simple. Well, actually, I know that. Well, how? Because I Googled for it. And Google said it's called simple, uncomplicated, casual, and common. But of course, for people who don't know the particular symbols in this language may look at this and say that's complex. But that would be naive, isn't it? So on the other hand, somebody who is very familiar with it immediately gets a grasp of it. So let's talk about a simple problem and talk about how the solution may really be complex, but how we could make it simple with something that may not be familiar to a lot of programmers, relatively speaking, to imperative style of programming. So let's say for a minute that we have this particular example code that you see right in here. So in this example, as you can see, I have a list of names given to me. And what I would like to do is to, let's say in this case, print comma separated. That's all I want to do. Separated names in uppercase, let's say, but of length, let's say 5. But how would I do this in the imperative style of programming? So a very simple code, but not a simple solution. The problem is simple, but not the solution in the imperative style. I could say for int I equal to 0, I less than names dot size, and then say I plus plus, and you say, oh my gosh, don't you know there's a simple loop that's a simpler for loop. So I could say for string the name, coming from names, of course, and then I could say if the name dot length is equal to 5, things are going really well, isn't it? Then you could say output name dot to uppercase and convert it to uppercase. Hey, that's great. But wait a minute, the problem statement says comma separated. So I could put a comma in there to separate them by comma. And you may say, well, it really meant them to be in a single line, you may say. And I could come in and remove the ln from the print line. But then when I do this, notice there's a silly comma in the end. Have you faced a problem like this? Every one of us. And we're in denial this is happening, isn't it? So how do I solve it? You think for a while, maybe I could create a string builder, I could strip things out, and then you're thinking, oh wait, there's a simpler solution, a colleague says. How do you do it? Well, keep putting the comma except for the last element. But how do I know it's the last element? Oh, for that you can write int I equal to 0, and of course names, I is less than or equal to names dot, is it size, and back to square one, and you say, oh my gosh, that's quite complex. Why would I want to do it that way? A very familiar solution, but a complex one. But may not be a familiar solution, maybe unfamiliar if you will, but something that we can use using a more modern API. Well, even though functional programming has been around for a very long time. So I could bring in a little utility called the collectors to help with us. This is called delegation and declarative style of programming. So we could say, for example, output names.stream, and we could do a filter on the name. And the filter operation says, given a name, I want to say name.o, in this case, length is equal to 5. And then I can say dot map a string to uppercase to convert it. And then once I convert it to an uppercase, what I could then do is to call a collect method and joining that result with a comma to get that completed. So the code becomes a lot more concise in this particular case, and we don't have to work so hard to implement it after all. So in this particular case, there's no silly comma in the end where the code begins to read like the problem statement. Given the names, get me the names of length 5, transform it to uppercase and join with the comma. So this becomes a lot simpler solution, even though we need to be familiar with functional style, stream API, collectors, and so on. More things to know, less things to do, and easier to do it as well. So don't confuse familiar with simple, and what is really familiar may actually be complex. What is unfamiliar may actually be simple or complex for that matter. Well, a lot of us are familiar with imperative style, but declarative style is simpler in general and removes the accidental complexity in the code. Well, simple has fewer moving parts in it, and as a result, it becomes easier to maintain the code, easier to modify the code, easier to evolve and extend the code as well. Well, we talked about a few things that are not simple, not clever, not necessarily familiar. Simple is not also over-engineered. Well, over-engineering is something we do a lot of times when writing code. Well, Rube Goldberg made the name by creating complex things and illustrating. I've got children who went through school where they asked them to build some Rube Goldberg machines. And I always tell my children, hey, they're preparing you really well for the industry after all, so we can go create more complex things. But the point is, we could all create, and we all have created very complex solutions, but we should really ask ourselves, can we eliminate that complexity and move towards simplicity? Sometimes we create complexity in the name of creating extensible code or in the name of whatever the criteria may be, but we should really ask ourselves, can this be simpler? But simple is not also terse. We often confuse between concise and terse as well. I once came across a code like this in the industry. And in fact, below this was a little comment that said, God help me, I have no idea what this means. This is an example of a very highly terse piece of code because it totally doesn't have any domain-specific knowledge or abstraction built into the variable names, which is really a big disservice in my opinion. Well, on the other hand, if you look at this test, you may say, gosh, that's a verbose test. And I would agree with you. So it's calling some rod cutter set price. It calls a max price. If there was a failure, it takes care of that by saying the test passed because it's expecting a failure. If there was no failure, it reports that it was expecting a failure. Can we make this concise? Now, just a quick history. Back in time, JUnit 4 did not have any capability other than what you see here. But NUnit was a unit testing framework for .NET. And NUnit introduced a concept where you could actually declaratively look for exceptions in the test. Well, the folks behind JUnit got wind of it, jumped on it, and the folks behind NUnit deprecated it because that was not a great idea. Then it was left behind in Java 5. Thankfully, of course, it's gone in Java 4. Thankfully, it's gone in Java 5. But what was the solution? The solution was to say, add test as an annotation and expected equal to rod cutter expression.class as an example, and then say set price and max profit. You may look at this code and say, yay, that's concise. But I'm going to say that's a terse code, not a concise code. What's the difference? A terse code is short, so is concise code. But a terse code waits to hurt you when you least expect, whereas a concise code is maintainable and serves the intent. In this case, the reason I don't like this is, if the test were to fail at the set price, unfortunately, this test will pass for the wrong reasons, whereas I want this test to pass only if max price throws that exception. So what should I do? A couple of options. Go back and write the verbose code. I would rather write a verbose code that's correct, or find a simpler solution. For example, a concise solution would be to use something like assert throws and then provide the exception and then provide the block of code that should only blow up, leaving the other method alone. So again, between these three solutions, I would say this is verbose code. This is a terse code, not desirable. That's a concise code, which is what I want to do if it's possible in the syntax of the language and the tools we use. So don't confuse terse with concise and simple code and eliminate terseness and the complexity that comes from it as much as you can. As Tony Hoare says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. The other is to make it so complicated that there are no obvious deficiencies. So we can create it simple that there are no problems, or we can create it so complex we don't even have a clue what problems there are. And so, well, we talked about what is not simple, not clever, not necessarily familiar, not overly complicated or over-engineered. So we talked about a few different things about not being simple. But we still have to answer the question, but what is simple? Maybe we can take a stab at it. So what is simple? I'm going to say the first one is simple keeps you focused. One of the most important things today is the attention, our own attention to attention of other people as well. So simple keeps us focused. So when we are, let's say, searching, let's take an experiment and think about it. Simplicity at various levels, if you will. So let's go ahead and do a search. So I'm going to start the browser here so we can point the browser to do some searching. And I brought in yahoo.com and I'm curious, I want to perform a search over here. But immediately I notice there are some interesting messages over here that I want to go through. Oh, canceled TV show, effective immediately. Interesting. What else do we have here? Oh, I can kind of look at various details. I'm always interested in some history. Why JFK's AD decided to tell her side of the 4-year affair. Okay, not such a great news after all. And then kind of keep scrolling down. Then you say, wait a minute, Venkat, why did you go to this page? Oh, darn it, I totally forgot. I wanted to search about this Java API, but I forgot about it. Let's try this again. Let's quit that. Let's try a search again. Oh, that's Bing. I want to do the search. And Bing says, welcome to searching. But then I realized, oh, wow, what a beautiful picture. I love animals. And look at how the close-up picture, I kind of wonder what kind of camera they took this picture on. I wonder where these rhinos are located. I wonder what is the relation between these rhinos. One looks like a baby, isn't it? But you say, Venkat, why are you here? Oh, I came to search the Java API. I totally forgot. But I'm curious. I want to know where these pictures came from in the meantime. Let's do the search one more time if you don't mind. And here I am. And here is a page that says, welcome to the searching. And yeah, there's a bit of a distraction here for me. But it says Google search. I'm feeling lucky. I want you to think about this for a minute. Imagine the day the engineer or the UI expert or the UX expert decided to create this page and comes down and says, here you go, here's a search page. And the boss is looking at it. And don't get me wrong, behind that click is an enormous complexity of a wealth of clouds and algorithms and machine learning and AI. But that's what the manager is shown. And the manager says, what in the world is this? It's a search page. You're like, there's nothing on it. Well, you can do a search. And in fact, I even added, I'm feeling lucky maybe. Well, maybe you should feel lucky may have been the response, right? But I'm not going to ask you the question. How many of us have the courage to create something like this? How many of us use Google? Well, if I'm in the audience where I can see everyone, almost all the hands will go up. But why do we use Google? The reason is we care about our productivity. We value our time. We like to keep our focus. So that's an example of design simplicity with respect the user. So I want the search pages to give me exactly that. If I really want to search about what TV show was canceled, I can issue that search, but not be thrown on my face like so. So one of the key things to consider is, what can we eliminate? A beautiful quote here. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. What can we remove so that things can become simpler in the design, in the code, in our lives? So that's one of the things we want to ask is, how can we go towards simplicity? And we can make things simple by removing clutter, removing unnecessary details, removing things so we can keep the focus of the users, focus of the programmers, focus of ourselves. Simple eliminates accidental complexity and hides the inherent complexity. Inherent complexity comes from the problem space. Accidental complexity comes from the solution space. If we can remove accidental complexity by simplifying things and make inherent complexity manageable, I think that's a big win. Well, we said simple keeps focus. Simple also fails less. When we write code, when we create software, when we create applications, we want things to fail less and we want things to fail gracefully when they do. If I were to ask you, why is the cover of the manhole circle in its shape? I'm sure this is a famous interview question somewhere, isn't it? And I'm sure there's a lot of answers you would get. But the most common answer you would probably get is, it's circle because it does not fall in. That's a good, reasonable answer. But imagine you don't say design a circle, but imagine your problem statement, call for, request for proposal was design something that doesn't fall into the hole. I bet you some companies want to create complex solutions so they can make more money. For example, it turns out each one of these shapes also will not fall in. So if you were to drop any one of these shapes into a appropriately designed hole, they won't fall in too. But then why circle when we can have any one of these? Well, imagine at the end of the very long day, everybody is coming out and the last person coming out is supposed to close the hole and takes one of these and says, hey, which direction do I put it in? Well, in a circle, every direction is the same. Just roll it over, let's go home. So it's also the ease of use in addition to failing less. It doesn't fall in and end up with more work to take this out, but also it's easier to just roll it over and walk away. And that's another benefit we get out of this as well. So simple is easier to understand and easier to work with. Well, that reminds me of an experiment I did a while ago. Well, suppose I want to compute what a prime number is. I may be tempted to write a code like this. Is prime, I can do int stream on a stream and find none match and look if anything is divisible. Hey, seems like a reasonable solution. But what if I want to take this a little further and I want to create all the prime numbers starting with a given number? Well, if I write if a prime starting with a number, and if the number is a prime, concatenate that to the output along with the remaining primes, otherwise skip it and just return the remaining primes. For an expressive code, how do I get all the primes? If a number is prime, take it and then along with it concatenate all the primes after that. Very expressive, very easy to convey what we want. Easy to say, really difficult to do. This code will not work. It'll result in a Stack Overflow exception, isn't it? So how do we take a good idea and implement it without failing? Here's an idea. We could say next prime here is going to take a prime, and if it's a prime number, it returns that particular number plus, if it checks if the next number is a prime number. If it is, it returns it. Otherwise, it simply returns the next prime of the next number. So essentially, we can write a primes here, but we are able to use a infinite stream API. So I say streams iterate on the next prime and then get the next prime and then limit the number of values and return it. In here, we are using a rather unfamiliar approach for many, which is an infinite stream idea. But the code is very concise, and once we get used to the infinite stream idea, we get a hang of it really well. So sometimes we have to pick up these techniques to become effective. But simple is also elegant. Well, talk about elegance. Why in the world is this picture the most beautiful picture in the world? If you really think about it, this goes back to the same thing we talked about earlier. It doesn't have any clutter. There's no ornaments. There's no noisy things. There is no wallpapers and pictures around. It's a serene, natural place of a lady who is absolutely giving out a beautiful, simple smile. That's what makes this work art of a genius, if you will. So given that, of course, we can always think about making things really simple. But I'm going to talk about an architect's dilemma. If you ever go to Boston or you live in the area, you can frequent this place. And I was drawn towards downtown Boston. This is the Trinity Church. And you may say, what's big deal about it? Looks like any other church. Well, I was mesmerized not by this church, but by the reflection of this church on this building. As it turns out, this is the Jan Hancock building in downtown Boston, and it shows a beautiful reflection of this church. The legend has it that when they were about to construct this building, the city wouldn't give permit. The reason is the city said, if you build it here, the beauty of the church next door will be spoiled by an ugly building next door. The architect took it as a challenge and said, I'm going to design it in a way the church actually is still beautiful after all. And the architect placed the building in an angle with reflective mirrors. And I have to tell you, I stood there so long admiring the church's reflection to the point my family threatened they're going to call cops if I don't move. It is so beautiful. If you ever get a chance to go there, do take a look at it. My camera didn't do it justice, but that's one of my favorite places to go just stand there and admire the beauty of this reflection. But there is elegance, there is beauty, and notice how simple the solution was to bring out the elegance. But simplicity takes time to evolve. I'm going to show you an example rather very quickly to illustrate the point. But simplicity doesn't come instantaneously, it has to evolve. As Richard Feynman said, if you cannot explain something to a first-year student, then you haven't understood it. Well, there's a lot I haven't understood, and I take time to understand, and it's a challenge. Occam's razor says, if you have two equal solutions to a problem, choose the simpler one. Well, when I was writing the book on functional programming in Java, when Java 8 was released, I was excited about writing about something that's not there in Java yet, which is tail call optimization. And I wanted to provide tail call optimization because I've done this in other languages. For example, if I say factorial and I do a tail call number times factorial number minus 1, a tail call optimization is where you perform the math right here as part of this call, and then this is actually not a tail call here. It's a regular call after all. So this is a regular recursion rather than tail recursion. But a regular recursion will fail because when the call stack is deeper, it's going to fail. But I've read books like Structure and Interpretation of Computer Programs. I've used languages like Scala, Groovy, and Clojure, which provide tail call optimization in different ways. So I said to myself, if they can do it, why can't I do it? Not a good idea oftentimes to have that feeling, isn't it? But I said, here's factorial, and I want to call the factorial, and if it is 1, I want to say done fact. Otherwise, I want to take the factorial and call it but perform the math before I call. So tail call is where you perform the math or the computation before you invoke the recursion rather than invoking the recursion and then performing the calculation. So tail call optimization has the benefit that it would not have a call stack overflow error. Well, nice idea, but how do I implement that in Java? So I spent about 10 hours experimenting with it, call me silly, and at the end of 10 hours, I found out that I probably have a solution, but it was not elegant. And I spent 2 more days of my life. And I came up with this after all. And I said, done is going to return an object, after all, in this case, which is going to say complete is true, and the result is the value that you were looking for, and apply will result in a null. Then I said, here is a function called isComplete, and the isComplete returns a null for a result. But on the other hand, when you call the invoke method, we'll go call the isComplete on that particular object. The invoke is calling the isComplete, and then it stores a current equal to the current object, and it says while the call complete is not true, keep iteratively calling the next one in the recursion until the recursion is completed. Looks like a reasonable solution, with except one problem. Look at this line right here. I said current equal to current.apply. That's mutating the current. Under the previous chapter in the book, I was telling developers, don't mutate, don't mutate, don't mutate. Here I'm mutating. I was stuck on this problem. How do I solve it? One solution I came up with was brilliant. I said, dear reader, notice that I'm using mutation. The solution to not use mutation is left as an exercise to the reader. Brilliant solution, isn't it? I thought so too. That would have worked 35 years ago when there was no internet and social media, at least not the way it is today. But today it won't work. People are going to tweet back saying, dude, what are you talking about? Show me the solution. Second solution, I said, dear reader, notice I'm using mutability. Don't use mutability except in cases where you cannot avoid. That felt like a really terrible idea also. And I realized that my code is terrible. So I left it there thinking I will probably ask somebody one day about how to solve it. And a few days went by. I was on the treadmill one day realizing how my solution actually sucks. And when I was on the treadmill, suddenly it occurred to me, I can use the knowledge I already have of actually using the Infinite Streams API just in a different context. So I immediately jumped out of the treadmill and ran to the desk and wrote the code, and it ended up being extremely simple. So the invoke method you saw earlier became just this. Streams iterate the current object, start with that, keep calling the apply method, but only get me the complete being true, and the minute you find the first one, you're done with the recursion, terminate. Well, that was a functional API, and it became extremely easy to write it, as you can see. I was blown away by the simplicity of this code, as you can see, and I took on to it. As you can see, it took me a lot of time, a lot of effort, kicking and screaming for me to arrive at this. As Einstein said, everything should be simple as possible, but not any simpler. But the question is, when I create a solution, I'm intrigued. Is this a simple solution? Or is there something simpler that I could potentially choose? And that's always the dilemma. Is it simple or can it be simpler? There are times I would solve a problem. I'll be showing it to a colleague or a friend, and they would say, but why don't you? And I would say, because I never thought of it. That's brilliant. That's simpler than what I thought. Let me refactor my code. So is my code simple or can it be simpler? Well, I'm going to say that question makes me think that simplicity is actually Schrödinger's cat. So my solution is both simple and complex at the same time. It's dead and alive. It is simple for what I know. It is complex for what I would eventually know. Maybe a colleague or a friend will point to me and say, you can make that simpler. So solutions are both simple and complex at the same time, and it's simple to what we know, and it's complex to what somebody else can show us how simpler it can be. But where do we stop? Well, my question is, where do we begin? Because the more we try, my biggest fear, honestly, is not that someone cannot make something simple. My biggest fear is they don't develop their skill to really make things simple in the long run. So every fight, every effort, every late night coding and rewriting and refactoring that we do is very well worth the effort. Not just for the problem we are solving, but to make us stronger, to give us that ability to go attack a problem and make it simpler. And the 1000th time you do, you wipe your sweat and you stand up and say, I can do it. And you are ready to face the next complexity and you want to attack that one. So everything you make simple not only can make things simpler, it makes you stronger. It gives you the power to go back and make things simple. And so when you see the slightest of things, the dullest of things, don't walk away from it, but take a second look at it and say, can this be simpler? And simple makes things really easy. But it certainly is not easy to make things simple. We have to evolve. We got to take the time. We got to put in the effort. We got to kick and we got to scream and we got to go back and do a lot of work. But like I said, it's extremely worth it, as we know from the wise words of Leonardo da Vinci, simplicity is the ultimate sophistication. It is worth every effort to make things simple and to even question and ask the question, is it simple or can it be simpler? to go ask a colleague, take a look at what I've done. Is this simple? Or do you think it can be simpler? But to have that open mind to say that we are good at what we do, but we can be better. We are good at what we have created, but it can be simpler. I think every one of that effort is useful, and I hope you will take your time to make your world around you, your code, your UI, your applications, and just the life around you simpler. Thank you so much. I hope you found that useful. We all are fairly good at what we do, and as time goes on, we develop this a little bit of an inhibition to receive ideas. Hey, I know what I'm doing. Why do you need to tell me there's a better way? So I think the first is to really, keep an eye on that and say, it's not a verdict. It's not a judgment about how good we are. And so when I sit down to pair with, a colleague or a developer, that question as to them asking why is extremely important. So from both aspects, when we pair, we need to, or when you do the code review, we should genuinely ask the question why. Why are we doing this? Is there a better way to do it? And on the receiving end, I think it's important also for us to say it's okay to be asked why, and then we can come back and explore a better way to do it. To give you an example, I was pairing with a good friend of mine on a particular code, and I wrote a particular solution, and he immediately looked at me and said, "Oh, that's complex." And I immediately pushed back and said, "Why do you say it's complex?" And then he said, "Well, here's the reason why I think it's complex. And if you write it this way, it's much easier." And then I had to say, you know what, you're right. I am infatuated with this way of doing things, but I can see why this may not be really useful for somebody reading the code. And that willingness is not easy, right? But we have to work on it and say it's okay to accept other ideas. So I think that's something we need to do from the person who is doing the pairing and the person who is inviting the pairing as well.
Yeah, I have to say I'm definitely guilty on the part of like being too married to a solution. So when new feature comes out, like when streams came out, I want to try them everywhere. And sometimes that you're making your life harder, that the for loop is actually perfectly fine. But then but I want to see, does it still work with the stream pipeline? So then I work hard, and then it may end up working, and then you're like, well, but that just makes everything so much harder to read. So I basically go back to throw half an hour of work into the bin. But I also think that sometimes you achieve a solution that then is actually simple, or at least you learn something about, in that case, maybe the Stream API.
Yeah, totally.
So generally speaking, what do you think, since we talked about the Stream API and you have a couple of examples including that, what role do you think play APIs or language features in that search for simpler solutions? And specifically with Java bringing specifically Java offering more language features over the last couple of years, but in general, same applies to maybe JavaScript or TypeScript. So what role do languages play in this search for simplicity?
I think they play a very vital role, because if you really go to the underpinning of complexity, one of the ways in which we end up really with a lot of complexity, or the accidental complexity in code, is by the imperative style of programming, where it's our responsibility as a programmer to specify every single detail. On the other hand, declarative style removes that accidental complexity. Well, if you really think of declarative style as a way of delegation, languages play a really important role in delegation. You are saying, hey, language, rather than me telling you in 20 different steps how to do this, I can delegate this to you in one call. Here's an example of that, right? If you want to read the content of a file, let's say, the age-old way to do that in Java, the scariest way to do that in Java is you put a while loop and you get a content and you check if it is not equal to null. I'm sure everybody cringes when we do it. But now you can simply say read string, and then that's going to just go grab the entire content of the file and give it to you as a string. Well, that's delegation right there, but that's declarative nature. So one of the nice things about languages, when I say the word language, I'm including not just the language capability or semantics alone, but the JDK or the standard library that goes with the language. You could say records are in a very similar way language features, and records say, well, rather than you having to sit down and do all that work yourselves imperatively, You can just declaratively say what you want, and it's really a hygienic. Well, so when languages are deficient, the patterns and annotations take root. And so generally, I would say patterns and annotations are smells, right? So think of patterns and annotation as deodorants. If the room is clean, you would need fewer deodorants. So language deficiency, shows up as patterns and annotations, and that's a sign for the language to say, hey, maybe you can grow and absorb those patterns and absorb those annotations. And if you really think about it, right, with all respect, Project Lombok is awesome, but records say, let's make that natural in the language. So I really go take a look at this as a fundamental delegation and declarative style. And the more mature a language becomes in raising the level of abstraction, the better it is for everybody on the ecosystem.
Yeah, so just to point that out, right? When you said it's a smell, you didn't mean like it's a smell in my code if I use a pattern, but in that case, it's more like a smell for the language. That if this pattern is like so commonly repeated and is used a whole lot, then maybe there's something that the language can do to make that obsolete or at least better. I think a good example for that is the strategy pattern, right? It's a pattern that
Yep.
where you pass action as data or behavior as data, and that's the thing like that used to be a thing really, but now with lambdas we think less of it. Like, yeah, every time you pass a lambda, you're technically using the strategy pattern. Well,
Bingo.
maybe not every time, like, well, I
Almost.
guess probably every time. But the point is, like, like you don't think of it that anymore in that way anymore, because the language made it so easy that you basically don't, even though you're technically employing the pattern, you don't think of it like that anymore. You get the benefit without having to do this mental gymnastics. Shai had a question in chat. He asked, how do you think the ease of debugging fits into simplicity? And the good example is, of course, the Stream API, which is surely harder to debug. Even with good IDE support, it's easier than it was like when Java 8 came out. But still, like going through a for loop is always easier than going through the Stream pipeline.
So the ease of debugging relies heavily on under two things. One is understanding the semantics, and the other is modularization, or compartmentalizing the code. To a great degree, if I were to ask you, in general, not related to streams at all, if I say, is debugging Java really hard? You're going to say, oh, no, debugging Java is really easy. You just put the breakpoint and off you go. And then I say, well, I'm so glad you say it because I have this multi-threaded code, and you're like, get out of here. Well, but why is debugging multi-threaded code really hard? Well, it's not that it's really hard. The multi-threading is non-deterministic. And when you switch over a breakpoint, the next line that's going to hit may be something completely different because another thread takes over. But over time, we have figured out ways to debug. You do isolation, you modularize your code. And in the past, right, I'm just laughing because I used to leave the debugger on when I went home. And then in the morning when I come back, I know exactly where to start debugging again. So I lived in the debugger, once in my life. Well, today, I write a lot more unit tests. And I'm not going to say we don't debug, but the way I debug the code is by starting with the unit test. So in other words, rather than debugging at large, it gives me the debugging more localized, or I can get to the function and then start debugging from there. And I cannot tell you how many times we start debugging with a unit test, and within a matter of seconds, even without finishing the debugging, I know what I'm doing wrong, and we immediately switch over. So we can modularize the code. For example, never allow multi-line lambda expressions. Modularize into a function and call it. And then, of course, understand the semantics of lazy evaluation when it comes to streams. So knowing the semantics and modularizing the code often makes it easier to debug. But that's again comes back to that familiarity, not just familiarity to the syntax, but the familiarity to the semantics is extremely important. In fact, I would say syntax is the least interesting part of programming. It's the semantics. When programmers use languages like JavaScript, the syntax of Java and JavaScript are not that widely different. They both take the C root, but the inheritance semantics in Java is so different from the inheritance semantics in Java. And so whereas class-based versus prototypal inheritance. To me, those are the interesting aspects. And once we leverage those, it becomes a lot easier to not only program with them, but to debug with them as well. So the first step is to understand the semantics, and the second step is to modularize the code to gain a better control over debugging.
Yeah, I think that what you mentioned there about understanding the tools that you're using, in this case, the API or language feature, is really important. And it also, I think, makes it so that there's no. I think simplicity is not a one-dimensional measurement, right? It depends on various things. So, for example, when you are familiar with a specific style of programming or with a specific API, then a solution might appear simple, or maybe then even be simple with all of that prerequisites fulfilled. That to somebody who's new to something would be much harder. Like, for example, again, with the for loop and the stream API, I think it's clear that for Java beginner, it's much easier to follow through what the for loop does, just going through step by step and tracking each item. Okay, this happens now. Okay, now I got it. Whereas if you understand the stream API well, then that gives you allows you to write a simpler solution, but it has certain prerequisites.
Well, and also on that front, quickly though, one of the problems oftentimes is we tend to really confuse the word "I am comfortable with something" to that is simple. So there's a complete, endpoints are different here. Something is simple or not is the attribute of what we are observing. Whether we are comfortable with or not is about us in how we feel about it.
Mm-hmm.
And I think these two endpoints are different, and we need to really recognize that. Sometimes we are uncomfortable with something, but that's not a judgment on its own complexity or simplicity. So I think that's where we need to, really explicitly ask that question to ourselves oftentimes, right? I catch myself doing this quite often, and I ask myself, wait, are you really saying you are comfortable with this? Or are you saying that it's actually simple? So there's the endpoints are different, right? One is an assessment of what you're observing. The other is an assessment of the observer. And those two are different endpoints. And we tend to really forget that oftentimes in communication, but bringing that out can also help us to identify and then to be able to say what need to be improved. If something is not simple, that need to be improved. But if we are not comfortable with it, well, then we need to really improve ourselves before we come back to improve something. So we need to really keep that in mind as well.
Mm-hmm. So you mentioned earlier, or we just mentioned functional programming in there. A lot of what you showed was very, had like a strong functional touch. What do you think does functional programming play for a role in this search to write simpler solutions?
The core underpinning for me when it comes to functional programming really is it's the declarative nature of functional programming. It took me a while to actually understand and realize this. We all run behind the functional programming concepts, but why is that even better? Why could it be even better? And I think the real reason is, I define functional programming as declarative programming plus the use of higher order functions. And so the higher order functions are interesting. People often focus on lambdas when it comes to functional programming, but I tend to focus on the declarative style. Part of the reason that's important to recognize this, when I came from decades of programming in imperative style. Functional style is not a natural way for me to think. It is something that I kind of adopted to, right? And it's kind of like speaking English. That's something I have to still work on because that's not my mother tongue. It's not natural to me. And there's a lot of time we want to say, how do I get better at it? And so to me, what helped me with functional programming was to clearly understand that it is a declarative nature, a declarative style. So now when I take a problem, I don't tend to really have the urge to think functionally. I tend to really think more declaratively now. Then I translate to functional style. I think that journey can really help developers to, make the transition a lot better in saying, let's approach this as an imperative versus declarative rather than functional.
Mm-hmm.
The other thing also that I think is important is, sometimes you come across developers who try to pitch object-oriented programming against functional programming. And I think that's also misguided. And the reason is OOP is not our enemy. There are good uses of objects, and I love objects when done rightly. But I think objects and functions mix really nicely. So what we are really trying to attack here is the accidental complexity that is, inherent in the imperative style, and we want to approach it declaratively and then, go on to functional style, I think becomes a nice transition.
Yeah, we have to put a pin in accidental complexity. I have a follow-up question on that, but I want to, of course, mentioning functional programming. Got a few replies in the chat. So, so what Anna wrote is that functional programming makes it easier to push out parts of the program into side effect free parts, and I think that shows a bit in your example with the tail call optimization there. I found it interesting because you later found a mutation-free variant to implement it by using the Stream API. But of course, mutation is still happening. It's just we don't see it anymore. So I think that's also important. Like mutation, that's my personal take on this, right? Mutation isn't bad per se, but it's bad if it's observable, widely observable mutation. If you change an object and everybody else has a reference to that object and everybody else needs to check or depends on that new state or has to observe when it changed, I think that's the kind of mutation that can really hurt. But having like a local system which is okay, I'm just going to mutate some state internally, but from the outside it will not be visible. Let's say, for example, like a cache kind of, right? So a cache has a lot of mutation going on the inside. Ideally from the outside you would never know. It just sometimes it's fast, sometimes it's slow, but you don't depend on the internal state of the cache ever. So I think that's where mutation has its place. I think that's functional programming does that.
I draw the analogy to that. I tend to use the word explicit mutation, where you are mutating rather than an underlying library is mutating. So even if I am mutating, the problem still becomes mine, right? But if they are mutating, it's their problem, which is great. I would rather have the other people's problem than my problem. But here's the analogy I want to really draw. And anybody writing Java code can really quickly look at it. If you were to write a code with a goto statement, you would frown on people today and say, oh my gosh, you're writing goto in structured programming. We don't use goto. Well, just simply write a for loop with an if statement in it, compile it into bytecode, and take a peek at the bytecode. What you see in the bytecode is a goto statement. So you and I don't use goto. Java doesn't allow goto. It's a forbidden keyword, but bytecode uses goto. That's kind of what I say. Goto is to structured programming as mutation is to functional programming. So you and I don't want to do it, but it can happen under the hood. That's fine. And so that's why I'm worried about explicit mutation, whereas I can do implicit mutation, much like I don't want to do explicit goto, but an implicit goto is just fine.
Yeah. Yeah, that makes a lot of sense. When we talked about simple a little bit earlier, there was a good comment by Kenzie. She said, it's like the word intuitive, which just means the way this works is the way I expected it to work. And there's no intrinsic, actual, measurable meaning to it. I think that's a fair point, right? It's really hard to distinguish, as you said earlier, like the observer and the observed thing. And I think we're in quite the habit to put both of these together and be like, well, we use something and we think it's intuitive, maybe because of obvious examples of stuff like high-end technology, which let's say a smartphone, which is easy for us, but maybe our parents have a little more trouble getting used to that.
Actually, if I can stay on that point for a second, that's a beautiful observation, and I would definitely say agree for most part. But there is a caveat in there. When I do code reviews, I fall into trap of this so often. I just simply laugh when I do it, because that's the trouble of intuition, right? The intuition is where our mind jumps to conclusion because based on what we are comfortable with, what we are familiar with. I cannot tell you how many times I would look at a piece of code I'm reviewing and say, oh, I don't like it. And then I would start reasoning why I don't like it. And this has happened a number of times. As I start reasoning, I would realize that actually is a good code, and I was jumping to a conclusion that I don't like it. Now I start seeing a different light of it, right? And then I would say, oh, maybe a small change here would divert me from my thought process so I don't fall into the trap of not liking it. So that's kind of the trick of the intuition is intuition depends on a context. Intuition depends on a familiarity, right? When you and I share a context, it is intuitive for both of us. When you and I don't share a context, it's not intuitive. That's the trouble of intuitiveness. Yes, we want things to be intuitive, for the people who share a context, that's a good design. But we have to be careful is that that context may not be the right context to actually share, and we may have to elevate the context for a better intuition as well. That's where the trick is, that we need to, it's great, but we don't want to really, conclude that that's an end point, that's just a journey to something else, unfortunately.
Yeah. I have one more question before I let you go, and that's about, I said earlier to put a pin in that, about accidental complexity. You mentioned that, and essential complexity. So just again, like there's some complexities in the problem, and then there's always some complexity in the solution. And what we try to achieve, I think that's what simplicity is to have as little accidental complexity as possible. Do you have like a heuristic or some other gut feeling that you use to distinguish the two? Like, is it right? Because if you want to get rid of one kind of complexity, but at the same time, it doesn't make sense to, try to reduce the essential complexity in the problem, right? So that time spent there is probably not helping, because the problem is as complex as it is. Like you can see, for example, the complexity theory, of course, is like a real thing, but also like with performance and runtimes, there are certain things that you cannot fight. That's like just the lowest bar. So do you have like a good way to figure out when you see something, well, what part of this complexity is essential and needed, and which part of this is just the craft that comes on top?
Yeah, that's a really good question, because we need to be able to actually discern between the accidental versus the inherent complexity. And I think that comes from the knowledge of the domain, the knowledge of the problem being solved itself. I used to work in chemical engineering, which is an alien concept for me. And I would look at the code, and all I can see in front of me is the sheer complexity. But how do I know if the complexity I'm seeing is a domain complexity or an accidental complexity? I have to say that I don't have the capability to do that until I elevate myself into knowing more about the domain. And this is where I would sit with the domain experts, try to have them explain to me what is happening, and then start sifting through and say, and then some of these people were, such an expert in their domain, they were really awesome in creating algorithms, but they were not good in writing code to express that, right? And so what they're doing is they are taking the domain complexity and then bringing in their own accidental complexity into it, and then delivering this piece of code. And then you have to really elevate yourselves to be able to say, okay, that's the domain detail, whereas here is a solution detail, and start sifting. One approach we could take is to find maybe 2 or 3 different ways to implement the same thing. So if we're able to get the same result in 2 or 3 different ways, now we are beginning to really sift out and say, hey, this is common between these solutions, but these are different. And maybe we are able to separate those two and say, well, on this one is the accidental complexity, which we want to reduce, whereas this is the inherent complexity. Maybe from the domain point of view, there's a way to attack it eventually, but not using solutions. So maybe, elevate yourselves, understand the domain a lot more. And I would say, never accept the first solution that comes your way. That's what I say about everything, right? I mean, you and I, have done this. We have written books and articles and, talks. You never take the first draft and say, I'm done. But how many times as developers we do that? We write code once and I'm done. You're like, no, you just started, you're not done. So it's important for us to really not only write code, but to come up with 2 or 3 different implementations, contrast it, and that can help us to, separate those two out.
Yeah, I guess tests really help a lot there, right? Like if you have good test coverage, you can be really sure that you actually have equivalent solutions that actually tackle all the problems and don't end up with one that is simpler because it's incomplete.
Yes and no. The reason I say yes and no is I am the person who is the most interested in test. But at the same time, the word you use there is the most important word if you have good test. That's the challenge in itself, because, I was in a conference a couple of days ago and somebody was asking about this. And I said, look, I look back, I've been doing test-driven development for 20 years now. And I remember 20 years ago, when I started doing it, it was very different from how I do it today, because I was writing tests all right, but those were not really good tests. It's a learning process we have to go through. And that's the real challenge, right? So if we say, oh, write tests and you're going to get a better result, I think the key there is what you said, write good test. But the problem is knowing what that good is. and that becomes, again, it's really subjective. I can happily say it's good because I wrote it, but unless somebody comes and evaluates it and says it can be better, that in itself is a challenge to really achieve on its own.
Yeah, that's true. And that, like, you can have, of course, you can write tests that are very specific to a solution, and then they don't actually lend themselves to write a second solution because you realize that you're not bound to, you didn't bind the test to the requirements, but to the code that you wrote. I want to close with something that Arne just wrote. I think that's actually a very good observation. He says, there's often new projects miss some intrinsic complexity. So basically they're, because it wasn't part of the design, so basically underspecified and there's some complexity hidden, or missed rather, and then it becomes tacked on with a lot of accidental complexity later. So I think that really, that's something that can actually happen where we realize later, oh yeah, we missed that part. And now we either, like, with the new requirements, do basically like a new simple rewrite, which is then often not going to happen, or we tack it on and we realize, well, that adds a lot of indirection or a lot of complexity trying to get this work. Venkat, thank you so very much for being here. It's always a delight to have you on. And if you have some time to hang out, that would be nice. But as we said in the beginning, I think it's the middle of the night for you. So you are excused. You are allowed to go to bed now.
Thank you so much for having me, and thanks, and stay safe, everyone. Thank you.
Yeah, sure. Bye.